Hey everyone, this is Sina with another episode of Into the Byte Code. My guest today is Georgios Konstantopoulos, the CTO and a general partner at Paradigm. So in this conversation, we talk about Reth, the Ethereum node and SDK that Georgios and team have developed, and we really dig into its architecture and design decisions that allow it to be performant, stable, and extensible. We also talk about some more personal topics, like Georgios' philosophy on engineering management and putting in place feedback loops. And towards the end, we zoom out and we talk about a potential future for Ethereum as a world computer. With that, I'll leave you to it, and I hope you enjoy. The last couple times we've hung out, I've heard you kind of talk about it being disappointing that all of the rollups seem to kind of have the same feature set or to be small iterations on the same thing. Why do you feel this way? And what's the alternative vision of what's possible right now?
So maybe let's go back in history to the original sidechains world. So sidechains was a concept introduced for the Bitcoin chain, where the goal was, okay, Bitcoin is slow. It's all supposed to be immutable. Let's try not to mess up with it a lot. Let's try to introduce additional sandboxes that help it scale and innovate. And the original hope was that things that were happening on sidechains for Bitcoin, you would eventually either port back to Bitcoin, or you would port things from Bitcoin to them. And, that would pave a way for a seamless upgrade. Now, fast forward, we had the layer 2 vision for many years, where even back in the day, we worked on Plasma, we worked on state channels. Then we discovered, okay, Plasma was hard to generalize. We discovered state channels were hard to scale to multiple people. And we came up with a compromise in the middle solution that we now call the rollup. And the rollup is a really powerful construct. It lets us construct trustless scaling solutions that are censorship resistant while having fewer participants running the network versus, say, have hundreds or thousands of people operating the network to produce the next block. But the innovation component somewhere got lost along the path. So one thing that you will observe if you look around the world in anyone building layer 2s today is that they're mostly forks of the Geth software, or they are importing a lot of Geth as a library because Geth is the best implementation that exists right now of a layer 1 node. And as a result, everyone building layer 2 nodes generally derives their work, which is amazing, and big kudos to the Geth team. What's the issue with this is that people are afraid to diverge from what the Geth stack provides. And why is that? Because people tend to fork the software, and when people fork the software, they don't always know where to go and modify things. So when people go and make pirate modifications here and there, the software might have unforeseen consequences. This might have unforeseen consequences.
I remember, not to interrupt your train of thought, but I remember that George Hotz did a small commit to the OP fork of Geth back in the day, right? Like four years ago or something like that.
Yeah, George had worked. I'm not sure if he had worked on the core OP or. Yeah, George had worked on OP Geth at the time, which was on a very different system from one that is today. And yeah, all the changes that were done back then were crazy. Actually, I had written a blog post on how does Optimism's rollup work, which would go really deep on that. And Optimism had used that as one of their main onboarding guides for new employees for a long time at the time. So getting back to the core point, if everyone is forking from a well-known node implementation and they're afraid to diverge, then the innovation component got lost. Maybe we achieved scale, but you're kind of bottlenecked on feature development by the rate of improvement of the base L1. So I think what would be really exciting would be to have a world where you can iterate further than that. A set of libraries that can help you go and innovate and experiment. Now, experimentation is really expensive in the sense that you will need a lot of security tooling around it to make it work, or you will need a lot of process to make it work. Because otherwise, if you look at, for example, say in the Cosmos ecosystem, when they try to introduce the EVM modules, whether it is a chain like Evmos or Berachain or anything like that, there's like a lot of work that you need to do to make sure that you don't get exploited by some issue. And there's like multiple great posts showing how, hey, the Cosmos SDK EVM module got exploited when it had a weird interaction with some other module in the Cosmos SDK. And that's very important to avoid. I'm on the one hand, you could say disappointed, but like I would take maybe the more positive view on it, which I'm really excited by some of the work that we've been doing with the Reth project to facilitate layer 2s that are able to innovate and go beyond what, let's say, the base L1 gives them. And to get to that vision, we have been developing a project that we've been calling Reth AlphaNet, where Reth AlphaNet is a high-performance experimental OP stack testnet rollup. So let me just break this down. It's a high-performance rollup, meaning that it's built for breaking through what we call the gigagas per second limit. It's experimental in the sense that it's going to allow us to try out new things. It's built on OP stack, which means that it leverages the layer 2 stack that Optimism has built and is able to use fraud proofs, forced L1 sequencing, and leverage all the many years of research that we've done over with the entire layer 2 community. And it's a testnet rollup. Well, it's a testnet rollup because we don't have experience running things on mainnet, and we'd like to run that on testnet to be able to iterate very fast. So by being experimental, and that's the core point I want to drive home, we're able to try new things out. So 2 weeks ago, where we last met Sina, we hosted Frontiers, which was a conference focused on all of the code that we've been building with the community. And we launched or soft launched with Conduit Reth AlphaNet with all the features available in the Prague hard fork. So the upcoming Ethereum hard fork, we have implemented everything, both on L1, but also on L2. So we launched for the duration of the event a network that has all the features from Prague, such as account abstraction, the EVM object format, and other smaller EIPs. But these were the two most important ones. And that is our first, let's say, foray into starting to accelerate, because I think we need to accelerate not just on the performance. I think we need to accelerate on the feature development of things. And my hope with all the software that we've been building, spearheaded by Reth AlphaNet, is that we'll be able to escape a lot of the local maxima and a lot of the things that people have told you for a long time that they're hard or that they're just too complex, that people hopefully can develop them in days or hours instead of weeks and hundreds of millions of dollars and whatnot.
Mm. What is it about the architecture of Reth that allows us to iterate at faster speed? Is it something about the architecture? Is it something about how you've kind of thought about constructing the teams working on Reth and how they kind of operate with each other? What is the scaffolding that allows faster iteration at a layer of the stack where, security and missteps are you want to be very careful about those sorts of things?
That's a great question. Reth, on the surface level, is an Ethereum L1 node. It's built to be fast, modular, and contributor friendly. What do these three things mean? Fast means that it's very efficient and is able to go fast. Modular means not modular code, libraries, and stuff like that, not modular blockchain, which is a very popular narrative that you will hear out in crypto. Modular code means that we were very, very intentional about the interfaces between various components, allowing you to swap them in and out. And thirdly, contributor friendly means that we are very intentional about extremely good tests and extremely good docs and extremely good contributor, maintainer culture, such that you can come into the code base and contribute new code without you kind of messing something up without knowing too much about the code base. So these three things are very important for what I'm about to say now, which is that Reth on the surface level is just an L1 node, but how we relate to the Reth project is that it's an SDK for building nodes. So Reth exists on L1. That's the node that has 5 to 6% mainnet adoption right now, and hopefully we'll have more in the future. Reth AlphaNet is the L2. It's the first party L2 that we're developing to accelerate and to try things out. And the Reth Core SDK is the SDK for building L2s. So what does that all mean? It means that we took a very intentional process for building the node in a way that while we're building the node, we can gradually extract components that are reusable and create very clear abstractions that you can plug into. Whereas the alternative would be, let me take Geth, fork it, make a ton of cowboy patches on it, and then end up getting hacked. Whereas what we observed is that with the Reth Core SDK, where we applied that on AlphaNet, we on 1,500 lines of code, just 1,500, like that's not a lot. You can write that like with Claude in half a day maybe these days. You can build a new L2 with new experimental features that people would tell you they're crazy. You can do that in one day. Why? Because the boundary that you can modify is so tight that yes, you can write your business logic, but you cannot screw up by accident. And so we were very intentional about our abstractions such that they give you flexibility without letting you shoot yourself in the foot. And there's a lot to say about the team also, but I want to first focus on the point around the code and how it was laid out.
We can get to the team later.
Yeah, totally. So it was very intentional.
About the code, like at the risk of going a little too deep, but I think it would be interesting. How should I think about the kind of core abstractions that exist inside of the Reth SDK? Like what are the core components of a blockchain node? What makes it easy to be able to go in and implement an experimental feature? Like, can you kind of peer underneath like some of these abstractions a little bit?
Absolutely. So actually, during the week where we did Frontiers, we run a full team offsite where we gathered and we roadmapped the full Reth Core SDK. So I'm going to tell you a bit about how does a node do things right now. So usually when a node is operating, it receives messages over RPC. These messages alternatively come from the peer-to-peer network. So how do things get ingested by your node? It's either peer-to-peer network or RPC. Now, afterwards, usually the node, when you get after the network component, locally the node is a processor. It takes bytes, like processes them, writes them to the database, returns some responses. So what you have is like RPC, P2P, execution, and then the persistent layer, which is the database. Specifically in crypto, where you have light clients. So for example, this is like less prevalent in areas like, in Solana, for example, you don't have a try. It has a flat state commitment, as we call it. After execution, you also compute the state commitment. And that state commitment is what we call in Ethereum the state root, which is a very powerful concept which allows you to do layer 2s, light clients, and other useful and bridges, for example. So the modifiable components that we had to get done in Reth was the RPC, the peer-to-peer, the execution, the state commitment, and the database. And these are very hard to like generalize in a very principled way, just because if you modify one thing in one component, you might also need to modify it in another component, and that ends up being like a lot of work. And where else you would see that is the Cosmos SDK and Substrate, where they were built from the ground up to be, SDKs for building chains. Whereas we took a bit of a different approach where we said, okay, instead of building the SDK first and then building chains, let's build a very high performance node. And then as we're adding new chains, using our knowledge of how nodes should work, let's try to generalize parts of that. So let me give you some examples. If you have a modular execution component, what you can do is you can run EVM, but you can also extend the EVM. What are the most vanilla ways you can extend the EVM? The most easy one is new precompiles. This is what everyone does these days, and I don't find that inspiring, but it's something useful to do. Where precompiles, you should think of them as, very high performance things that you cannot bolt into the EVM. So they're native code that gets executed outside of the EVM. New opcodes, which again, custom opcodes, custom precompiles, more or less the same thing. But you can actually do much more interesting things. For example, you could do a mixed runtime. You could do EVM plus some other execution environment. For example, Arbitrum is trying to do that, where you can write EVM code that is written in Solidity, but you can also write Rust code that compiles down to something that you can do a nice runtime that's mixed between the two. There's also another excellent project by Leo Alt of the Ethereum Foundation called R55, which is RISC-V mixed runtime with EVM. So I think there is something to say about like modular execution layer allowing you to have like dual runtime, and bootstrapping something that starts with EVM, but also allows you to also tap into like non-EVM developers at the same time. And this is a tale as old as time. Solana was basically saying, oh, okay, we'll let developers write Rust. And clearly that resonated with many people.
Yeah.
So in terms of developer friendliness,
so dual runtime, just to kind of double click on this point. So you mean that there can be smart contracts that when you kind of look into their bytecode, there's two different instruction sets or two different VMs, and based on what the kind of interpreter sees as it starts parsing that contract, it chooses what runtime to go into. And this allows you to kind of both have this EVM equivalence thing that we all want. So you can kind of keep, allow Ethereum developers from everywhere to continue writing Solidity, but also not get pigeonholed into being backwards compatible forever.
Exactly. And I think it's very important to be backwards compatible in the beginning to at least bootstrap. But I think you realistically cannot prevent people from like trying new things out. Like people will try all sorts of crazy things. So give them a nice way to do them. That's why for the mixed runtime, that's why I'm a big fan of the EVM object format proposal, which is slated to go live in Ethereum in the next hard fork, Prague, which is, it's a principled way to reason about your bytecode. Right now, the bytecode does not have any, explicit format. It's like, take the Solidity bytecode, compile it, and it's like a bunch of opcodes like next to each other. Whereas right now with EVM object format, we can create containers that have an explicit prefix that says, hey, this is a RISC-V bytecode layout, and this is an EVM bytecode layout. And the interpreter can the interpreter doing it on the interpreter level is easy. You can always inspect, the first byte. But if you want to build developer tooling around that, which we have built a lot of developer tooling with Foundry, Alloy, and others, it's important that the developer tooling knows what the bytecode or
without having to execute the file, like you want to just parse a code base. Yeah.
Exactly. So it's very important that like the bytecode format is very structured such that it can support having a principled way of like reasoning about multiple runtimes. So I like throughout our conversation, what you will hear me say a lot is like principled, because everythand you want, you can do in any cowboy way that you want. Like we're fine with that. We know how to do that. We've been to hackathons, throughout the years, and we've seen like code bases that are able to do the thing, but they're not principled at doing the thing. Whereas if you want to build something for 10 years out, and if you want to build a proper team around all of that stuff, you need to be a bit more thoughtful. And so that's a core principle of how we do things. Like we try to be very adamant about, okay, this has to be done the right way, and that the right way will take more time, it will take more effort, but it's always worth it.
Yeah.
So just to get back on the SDK and the modularity point and like getting under the core components, one exciting component that you can modify for developers is the runtime. People have started doing that right now. We'll see where people get. Other very basic things that you could expect are custom RPCs. So people want custom RPCs. People actually sell them. If you look at Alchemy or any of the other big RPC providers, they give you, endpoints that say Alchemy _ get ERC20 balances. And they do some nice things. They're not that crazy things, but they're like nice things. It's useful to expose some additional RPCs. How people have been doing that again is that they fork Geth and they try to do it on their own. And anytime I've seen a code base that does this on their own, it's a bit painful to watch. Whereas in the Reth code base, we have examples that illustrate, hey, like by doing .extend RPC in your main file, you can get a new RPC in 20 lines of code where you, instead of doing fork Reth and do all your mods God knows where, what you do is that you do use Reth CLI or import Reth CLI, and then you build your own binary where you're importing Reth as a library. So that goes back to my point that Reth is not just a node, it's an SDK for building nodes. And it's an SDK for also building not just L2 nodes, but for modifying the existing L1 node. Whether it is a custom RPC, you can think of the same for a custom transaction pool, for example, because maybe you want to build a high performance memory mempool that, maybe me and you, we have a very high network, great networking connection between the two of us, and we want to create a private mempool for that. Another example that you can use Reth as an SDK for is for MEV. So MEV people are generally the early adopters of any kind of bleeding edge crypto tech that you see these days, because if you can get faster, if you can get more expressive, that's more money for them. And what happens with all of these guys is that they look at the fastest thing that exists and they want to modify it. But if they modify it again in an unprincipled way, they might do something wrong and that will cost them dollars. So for us, giving them a great API to modify the node and to extend it and to use it for MEV was extremely valuable. And we know that MEV people have been using the Reth project since the very early days, even since the early alphas. And they're always pulling the latest main on GitHub to make sure that, if there's a 1% benefit, they can get access to that. More recently, Flashbots released our builder, which is an MEV builder built in Rust, built on Reth. And they also presented that again last week at Frontiers, where that's clearly demonstrating the power that you get from importing a bunch of very polished libraries instead of you having to figure things out on your own. And this goes back to our core principles as a team, that we exist to empower developers. And by empowering developers, you don't just, build great stuff. You think very deeply on how can I prevent my developer from shooting themselves in the foot? How can I make sure that, you don't get one dissatisfied customer, quote unquote, in this case, for your software?
Yeah.
Other areas where you can think
maybe hold on. you got a lot of stuff to share. Maybe again, double clicking here just to make sure I and other folks understand. Let's take the MEV example, or say our builder. How would they use the Reth SDK? What are they exactly doing?
Totally, yeah. So the simplest thing that you can think of an MEV builder is it's just a modified block builder. Sorry, this is tautological. What's an MEV builder? It takes a bunch of transactions and packs them up into a block. By default, nodes look at their mempool. They pick the top whatever transactions by fee. They package it up in a block and they send it out. That's usually called the vanilla local block building. Whereas an MEV builder, they have a different algorithm for computing that best block. And not only that algorithm does not only pull from the mempool, it pulls from other sources of the so-called private order flow, or from other, mempools, which might be behind subservices, for example, Fiber or a chain-bound service and others. So what Flashbots would need to do, or what would any custom app builder need to do here, is swap out the default quote unquote payload builder with their own custom building algorithm. And that's all you need to do. Flashbots specifically went the extra mile to do some of their own modifications and optimizations and other stuff. But the most vanilla thing that you should think about is literally, I need to swap out the payload builder. So usually swapping the payload builder would be a lot of work. Here, in our case, you implement an interface, and in your main file, you say, dot payload builder, my payload builder, instead of the default one, and it's great.
That's it.
Yeah. So in general, the whole Node SDK, how it works is that by default, it gives you good implementations of things, and then you can override them when you have imported the so-called node builder. So in software, there's this very common pattern called the builder pattern, where what you do is, if you have a structure called foo and you want to instantiate foo, you do foo semicolon builder dot bar dot baz dot whatever, and then you do dot build, and that gives you back an instance of that. And that's a very common pattern everybody uses for a ton of small things. But I think this is the first time we've seen it done, at such a big thing for a node. Yeah, exactly. Yeah. And by being able, the builder pattern is amazing at this, because the node is a very clear system, clear components that can be swapped in and out. And I can just say dot this, dot that, and I have a great API that's totally idiot-proof, wires everything inside for you, and just very useful. And people like that so far.
Makes a lot of sense.
Yeah, and that's actually how our layer 2 integration also works. So Reth also supports OP stack, as I said earlier. And on the OP stack front, instead of having to re-implement the whole thing, we had a few thousand lines of code that implement OP stack specific modules. And then at some point we do dot types. Even the types are configurable. So like if you want to have a blockchain with additional or different transaction types, that can also support that, which is again really powerful because now you can introduce account abstraction types, for example, or the deposit transaction type. And again, you don't need to be an expert on the whole code base. You just need to like learn, hey, here's the integration guide. So you need to do this much instead of, having to like navigate a 100K plus LOC code base.
Into the Bytecode is sponsored by Splits. Are you tired of sacrificing security for usability? Splits believes it's still way too hard for teams to self-custody their on-chain assets. They're building a new kind of internet-native bank on top of Ethereum. Splits makes it easy for teams to manage the whole lifecycle of their finances, from structuring revenue sharing agreements, using payment flows like splits and waterfalls, to managing those earnings once you receive them, using passkeys and smart accounts. Splits is being used by teams like Protocol Guild, Zora, Songcamp, and others. I'm a big believer in them and recommend checking them out. You can learn more at splits.org. This is awesome. It's going to be such an amplifier on the productivity of the whole space, I feel. Because before you would have to try to understand the whole system and hold it in your head and make sure that your small change doesn't break anything else in the dependencies. But now you're giving people like very clean, like dependable interfaces. And you're like, you can swap out this piece and do whatever you want. You won't break the rest of it.
Exactly. So it's like putting you, it prevents you from like, derailing in unexpected ways.
Yeah. This point about MEV builders makes me think of this concept of building with feedback loops that I've heard you talk about. And like, this is an interesting feedback loop. Like, how do you think about feedback loops in the context of Reth? But also, is this something that you kind of more generally use in your work?
Yeah. So obsessed with the theme of a feedback loop. If there's no feedback loop, you have a big issue. I think this carries over from software to people management to your personal development as a human, actually. And maybe, before getting too philosophical, just on the Reth side, I think there's 3 basically core feedback loops. There's the performance, there's the extensibility, and there's the stability one. So performance, stability, extensibility. What do these 3 mean? For performance, and when you have a feedback loop, like in software, at least you want to define some kind of a metric that you're trying to hit, and you're using that like as your feedback loop. So for performance, we defined the metric that we call gas per second. I think that's kind of like an obvious thing, and I'm shocked that like people haven't been using it more widely. Where basically we say, all right, for high performance, we're going to try to max the gas per second that the node can do. And we're going to establish a very clear methodology about that. And for that methodology, our goal is, chart number go up.
Methodology, like the metric is defined according to methodology?
Sorry. How do you benchmark in this particular case? So it is for this piece of hardware, for this piece of load, you try to not make any changes that might, influence your measurement. Because when it comes to benchmarking is a scientific project, and you have to be scientific. And in science, there's this very standard thing that you change only one variable when you're measuring things. If you change more than one variable, you don't know where did things happen. So in our case, we fix the hardware, we fix the load, and we measure, let's say, every week. And this then proceeds to give you a gas per second number. And if that number went up, we're great. If not, we had a regression, and that's a problem. In the ideal case, people that do any kind of performance benchmarking, they should be having regression tests that check on the CI, so on GitHub. If there is something that showed your code be 5% slower for any reason, 5% more expensive in gas would be an alternative because you were writing a solidly smart contract, your CI should fail and you should not accept that pull request. So that's a general cultural thing that I think that anyone that respects themselves in doing high performance, they should have CI for performance. That's table stakes, and I think that's super important. Now, on performance, gas per second is our feedback loop. So that gets us to high performance. But we also use other things like common tools like flame graphs, where a flame graph is like a PNG image that you get after profiling your code, which gives you a bunch of like wide red bars. And your objective is to take that wide red bar and make it like less red and like less wide. Like if you think about it like in a very simple way, thing that takes a lot of time in the image, your goal is like make it take less time in the image. Mm-hmm. So if you can do that, that's a great profiling, loop for you to be in. Because you're like, okay, I made that smaller. And when you've made it small enough and you see other big ones, you're like, okay, that one is worth more of my time instead of the thing that I've been looking at. And like a common issue that you see in many junior developers is that they spend like hours and hours optimizing and refactoring a bunch of code that never gets hit. Mm-hmm. So that's like a common mistake. Like if you see anyone doing that, like please avoid. Mm. So that's on the performance front. On the stability front, there's again a very excellent feedback loop for us, which is the biggest staking network that exists today, Ethereum. So if Reth is good enough for people to run it on Ethereum L1, then it's stable. Simple statement to believe. Ethereum stakers in particular, they stake, 32 ETH, which is a lot of money per node. And if a Reth node has a problem, then they wouldn't run it. So if we see more people running Reth, that's amazing. And that's also in part like, many times people will ask us, do you want Reth to overtake Geth or Nethermind? And for us, no. Like the answer is like obviously no. Like because there's nothing to win almost by trying to like grow too big. Like you want to keep it up to a level where you can sleep.
The feedback loop is around stability. You don't get any additional prizes by being a bigger percentage of the L1 network.
Exactly. Precisely. So for us, it matters that like enough people use it. But after some point, like that tapers off. I don't know how much that is, but I would think, I literally don't know how much it is. But as long as people trust it, then like we're really happy with that. And that gives us confidence that it's okay, this is good software. The third one is the extensibility feedback loop, which is, or the extensibility feature. And the feedback loop is how many people import Reth in their dependencies. So if we see that go up, feedback loop metrics, pick your term, right? So if more people use Reth in their cargo toml, then that's a success. And that's a clear case of Reth being used as a library, not as a node. So the first two are Reth being used as a node. This third thing on extensibility is being used as a library. Now there's a fourth one, which it's kind of like not as commonly said, which is how the number of GitHub contributors. I care a lot about the number of GitHub contributors. I think that's actually the key thing that has given us all of the adoption and distribution that we have so far. And I think it's a key thing to measure how many new contributors do you get. So right now we have about 800 contributors, unique contributors across all of our code bases. Of note, we employ less than 20. So that's, big amplifier across all of them. And of these 800, for example, the Reth project had 500 pull requests and 50 contributors, including our team, 50 in the last month, which again, it's a lot. And that's why it goes back to my point on you don't want to be forking Reth, because if the Reth code base changes 500 PRs a month, at some point you will need to pull the upstream changes into your project. And I don't know if you've been through that, but anyone that's been through a rebase, long rebase, when the upstream branch has diverged way much from yours, you want to, it's like just ridiculous. So
it's like the equivalent of not doing your taxes and being 2 months late to it.
Totally. Yeah, exactly. Might be worse. So these are the four things that I measure, let's say, when thinking about the success of the Reth project. Now, on top of them, we also have the rest of the tooling, which is like Foundry, Alloy, like Dragon, like building Revum, like WAGMI VM built by the Webum guys. So there's a whole ecosystem of things around them to support the core, which supports the core Reth project. So there's a full stack, let's say, coverage. So even though Reth is the SDK, it has a bunch of like very useful things around it, because like if I'm a Solidity developer, I don't know Rust or I don't know Reth. I just want like to write my things. But if Reth adds a custom feature, then that custom feature needs to be exposed somehow to the developer. So that's why for us it has been very important to have the full stack ownership. And some people might feel uncomfortable by it, but we think it was necessary to like get us to the next level, and we think that the numbers speak, and we think that this has been important for the entire ecosystem. So we're really proud of that work, and we intend to continue doing a lot of it.
Yeah, it totally makes sense. I mean, it's like a vertically integrated open source stack, so you kind of get the benefits of both of those approaches. And yeah, if you make a change deep in the stack, you want that to be exposed in all of the libraries above it. Before we forget, how do you use feedback loops in the context of teams or even personal development?
Yeah, so, well, it's important to be able to take feedback, I feel. And feedback is not to be confused with like me shouting at you or me ranting at you about something that you screwed up in some way. There's like an art of like giving and receiving feedback that many people are not, interested even in engaging. And giving good feedback is really hard. It requires you to think. It requires you to not vent at someone for something that you felt they didn't do right. So I think that general for team development and for personal development, being able to react to feedback without ego is extremely important. When somebody gives you feedback, it's very important to repeat the thing back to them to make sure that you understood it, and to brainstorm with an open mind about it. If you have any sign of defensiveness, not only are you going to make sure that the other person believes that you didn't hear any of their feedback, you are going to deprive yourself from them giving you feedback in the future, because they're going to be like, okay, like Georgios is an idiot. He doesn't listen. Why would I bother? It took me so much to like go and give him that feedback, and he clearly didn't hear it. Why does it matter? Whereas if you give me something and I engage with it with an open mind and be like, that's a good point. I didn't think about that. And then you riff on it together, and that's quite exciting, because that means that I heard you. 2, I want to grow. 3, that further deepens our trust, actually. And I think there's like very little benefit to having relationships in your life where you need to walk on eggshells, or you need to be, sorry, maybe I'm butchering the phrase, but you want to be like careful.
I think that's right.
You want to be careful with like what you say, like to that degree, because ultimately then you have a fragile relationship. And I think with everyone in your life, you want to be like deeply engaged, authentically and honestly. And so you should be willing to take the feedback and engage with it. 2, when giving the feedback, you should be extremely thoughtful and not like attacking almost the other person. A lot of this, and I know you asked me like before we had this call, like a lot of this like are learnings that I got from working very closely with Matt, my boss, where basically I came into Paradigm as a loud Greek, let's say. And we went through a lot of sessions, a lot of feedback, funnily enough, where we iterated on achieving like a very open and truth-seeking, call it, way of engaging with things, versus being very stuck in your socialized or self-authoring mode. And you want to be as much as you can, you want to be self-transformative and not hang on to, let's say, your quote-unquote previous identity because you just have ego about it. And I think that's like really important for like growth. Basically saying, it's not like me. It's like, here's my goals. Here's how I need to evolve. And I'm willing to forget the things. And unlearning is the hardest of all, because you might have deep habits that are deeply rooted in your psyche from, maybe 20 or more years ago. and you just need to work through them, and that's hard.
Yeah, yeah.
And when it comes to teams, I think a lot of this applies. I think it's very important for teams to have, well, in teams it might be a little rougher, like when you have like larger teams. So I think it's very important to like protect the candidate or the employee. When you're doing things, you want to facilitate, when you can, you want to facilitate ways for people to do things anonymously. Because even though you might have a very quote unquote safe culture around things, for example, in the open source culture that we have inside of our teams, or even at Paradigm, people are generally super direct. So the culture is say what you think. Everyone like got it. Like everyone is like developed enough that they will deliver the feedback the right way. But like if you censor, that's like 10x worse than like saying something that might hurt a little. And you might need to develop like some like thicker skin sometimes. But I think it's still important to have the backup that, okay, always you should allow people to have like a safe place to like give the feedback, because no matter how much trust you have, sometimes people don't want to do it. So I want to like basically drive the point home that it's not just you just cannot be ruthless about it. You have to be also very empathetic about the other person, and that's very hard. That's very important to develop. And I think many times heavy engineering orgs forget about that, and they develop this kind of like cutthroat culture, which I don't exactly love, despite being like very direct myself.
Totally. I've liked the kind of radical candor framing in the past.
Totally.
Yeah. When I was at the EF, we kind of did a shared workshop around that with a bunch of people on the team, and it was really nice to kind of have that shared language after too. Thinking about how you kind of have designed these feedback loops in the context of Reth, right? So there's performance, stability, extensibility with like specific like metrics that they're being benchmarked on. Is there any way of applying that to yourself as a person? Or is it like more of an intuitive process of like, I know I want to grow in this way? Or do you have like actual metrics under the hood?
I wish I had such discipline. I haven't, but I've been trying. Like, I would like to get, for example, like when it comes to like physical training, I actually think that like, being great at your job also requires you like to have like a healthy body. If the hardware is not good, the software is not gonna run. So I've been trying to like do better at that, but I think sometimes it's like hard to apply, even though things like very well. Like I've been blocked on this at times in the past. So definitely like a lot of room for improvement there. So no, I don't have like as much of a training mindset like in everything in personal life. Sometimes I find it like very useful, like regularly train in music. So for example, like if you have like a set of things that you want to do and like regularly improve, whether it is playing an extra genre on your guitar or, like playing a longer DJ set or something like that. I think that these are like really interesting ways to like put yourself in a training mindset. So I think the most important thing for all of this is like just going and doing the thing like over and over, which I'm like good at.
Yeah,
just
quantity leads to quality.
Yeah, exactly. Go and do the thing.
So going back to Reth with these 4 feedback loops, how do you and kind of both the code structure and like all the teams that are working on this, how do you then decide what to actually work on? How are you prioritizing a roadmap to maximize these metrics?
Yeah, so this depends on team size, right? So what got you here will not get you there. So like for us, we're in a very interesting point in the project where we are in dire need of structure and of like more concrete ownership, management, and so on. So just to give you some context, we've been running this open source work for like 3-4 years, basically as a pirate crew. Everyone on the team was hired from GitHub without an interview process. The interview process was effectively the continuously showing up on GitHub, which is really exciting, but also it means that we never were super intentional about, okay, here's like the structure, right? So
also another cool thing from Frontier is I think you said that literally every single person is from a different country.
Oh yeah.
which is
That's a
so
funny
cool
stat. That's a funny
as an
stat. Yeah.
open source, project to have that sort of a thing.
Yeah, of the 16, and if you add, it depends on how you count, but yeah, like basically we have over 15, like we have over 15 people and over 15 different countries in the team.
Yeah.
Which is like really exciting. And actually, like, not to derail from the previous point, but it's really interesting to see how if you have multiple ESLs in the same room, the communication is kind of like forced to be like concise, precise, and all of that, because otherwise, you would not understand anything. And I think most of us like speak pretty good English, but like again, like you can even hear it like on me, like throughout the call, that like sometimes you will mess something up, and so it's like really important to like be really precise like in your communication, especially because of different countries and different languages. The other thing is time zones, so that also trains you very heavily on like being like very precise in your async communication, which I think is like a big predictor of team success, like being able to be good writers. So yeah, on management, feedback loops, yeah, like basically we were running the team like as a pirate crew for a long time, where decision making and prioritization was kind of like, basically me calling the shots for everything, just because I have a lot of context from the Paradigm investing and research work, and from working with many companies in the industry, most of which are in our portfolio. And like you could think of me as almost like in the PM role, where you receive like a bunch of context, you mash it a little, and then you send it off to the team for execution.
You're like a Reth node yourself.
Yeah, amazing. Yeah, like I wish I was that fast. So the structure is going to be really needed though, because all of this worked so far well when we had few people using the software, whether it is Foundry or Reth or Alloy or any of these. Like a lot of people use our software, but our priorities come from like a very specific high signal group of people that like we have curated over time. But over time, just the surface that you're covering grows. Maybe you want to end up commercializing part of things in the future. Like we want to be ready for like any kind of change that we want to introduce in the future. And so I think it's important that we introduce structure in the team. So we're going through that exercise right now, where we're developing more structure in how decisions are made, how priorities are decided. If you come in like to me and we're good friends, I don't suddenly P0 everything that you request, and that we actually have like proper priorities that are respected, such that we can say, in the next 3 months, this is what's going to get shipped, versus people overworking themselves, or unclear priorities coming in, or dropping worse. Or dropping requests that come in that are actually important, that we said we would prioritize, but we didn't. So I think the most important thing of introducing like clear structure, which is like an obvious thing, but it was not obvious to us until we felt the pain, is A, to avoid people burning out, 2, to ensure that you have perfect SLA. If you said you would do something, you do it, and no zero drop balls allowed. And I think that's actually a general in principle of being a good professional. Which to be clear, I'm still like learning at it, and I will still make mistakes on, which is zero drop balls. And I think earlier you were asking me what's a feedback loop, or like what's a metric that I hope to hit for myself. I think that's a great one. Zero drop balls, no exceptions, no excuses. If you drop the ball, it's not about you making up an excuse. It probably goes back to time management. So it's not like you saying, hey, I missed something. It means that, hey, you did actually upstream did not manage your time appropriately, and this goes to team management.
I like zero dropped balls is like a better way of saying like inbox zero and the sort of things that's getting at. It's like totally. It's like inbox zero tied into the importance of the thing that we're talking about.
Totally, and I definitely recommend being an inbox zero type of person. I think it's like required, especially if you're like in a in a routing role.
Yeah.
No.
One other thing, I was asking a few mutual friends for potential questions in advance, and one thing that Liam shared was that you have this habit of writing these like zoom out kind of comprehensive documents at specific points in the journey, and these these are both helpful for you to distill what you think, but they're also helpful for communicating to other people, kind of a shared vision.
Yeah.
What's behind that practice?
So behind that practice, how do I go about this? So I came into Paradigm a very tactical or instinctual person. Many times I did the right thing, many times I didn't do the right thing, but like all the time it was kind of instinctual, not as intentional, if you will, kind of like go where your gut takes you. I think over time I realized that you have to zoom out, slow down, take a breath, like realize what's happening. And I think I have a doc that I call Zoom Out, which by now is like an 80-page doc with like notes, and also a journal where I would like, on a weekend I would go and like just jot down my thoughts. Well, I think it's very important to do this because you want to declutter, so you want to have a safe place for like many of your strategic thinking or the feedback that you want to give to people, and then you want to look back at all of this and like synthesize into some higher level insight. So I don't think I have like too many, crazy things to share about this. It's just, trying to create self-awareness. Liam is particularly very good at that. Like he has like massive docs where he notes every week that he goes
I've
through.
seen them on Obsidian.
Yeah, exactly. Yeah. So I never went through that. What I really like is like ending the day with a very important question that's like really top of your mind, and then thinking about it in the next morning before any inputs. I think that's like a very good way of leveraging your subconscious
Interesting.
to basically get things done.
What sorts of questions? Like
something important, strategic for your work or for your self-growth, something that's blocking you, something that doesn't have an obvious answer, something that you need to like actually think about. It sits a lot at your stretch point, right? So like really training yourself to like operate at this stretch point is really important. And I think that the reason for the zoom out, like docs or like write-ups that I do for myself and for others, honestly, because, after you have digested your thought, you can then package it up and send it to someone. Hey, here's like what I thought about recently. Or here's like one area where I improved on recently. I think these are very important. Just to give you a concrete instance of this, like I've been trying to redo my entire schedule. Basically, I'm like in this mode where like I have massive, my calendar is basically like insanely bad. And like it requires you to like retake control of your day. So like one way is like, okay, how do I re-architect my day? And being very intentional about that and thinking about that and then communicating it to people around you is like extremely important. And any experienced like exec that might hear this conversation might think, hey, this is like obvious time management stuff. Where for me, it was not obvious because I went from like very deep IC mode where, I would like code every day to like eventually like not coding almost at all. And, I think that many people that are capable engineers might go through a similar journey. So it might be useful to them and less so for, the experienced exec that juggles a ton of meetings or a ton of demand on their time.
Yeah, that's a really nice one to close the day that way and start the morning with that. I feel like I've talked about this a couple of times in previous conversations, but I've been reading the long Alexander Hamilton book, and he was a very, very prolific thinker and writer, and this for many days, across the years, he would go to bed thinking about a question, wake up, have strong coffee, and just write for like hours.
Exactly.
And yeah, it's because there's a certain way in which you're fresh in the morning before everything else clutters the mind.
Pre-input, pre-email, don't check your phone, like no screen, just go. The other thing like that, like you might recall or may not recall, I don't know, like from when you were in high school or middle school, is like, sometimes you have a puzzle that you need to solve for, over the weekend or something, or some task that your teacher put you. And, your end of day, there's no way for you to solve it. But somehow you jot it down and then you wake up the next morning and voila, like the solution comes to you. Or with other people, this happened with showers and stuff. So I think it's kind of like interesting to see how the subconscious does its job at times.
Yeah. I'm curious to dig into one more Ethereum question before closing, before like a couple of fun personal ones. So when you have a lot of kind of unique perspective and context across the space, and you're kind of building for this world where the kind of Ethereum node is no longer just a node. Like Reth is not only a node, it's an SDK. And there's, this is going to lead to this proliferation of layer twos, of services around blockchains. The whole kind of transaction supply chain is changing in many ways. Maybe because this could be a very big question. I basically want to ask you, like, what do you think the Ethereum stack / ecosystem will look like if we snapshot it in like 3 years time? But that's a very big question, and I'm curious, like, how you would answer the L2 centric version of that. Do you think we're going to exist in a world of every application is on its own layer 2? And how do these kind of interoperate with each other? What does the account model look like? Like, do you have a coherent vision of what that future looks like?
Yeah, I have one vision, which people on my team, anytime I talk about, they think I'm a bit crazy. So I really like the idea of a decentralized cloud, or the so-called world computer from back in the day. Clearly, you cannot scale one monolith to world demand. Clearly, like well established. Just look at the internet. There's like clusters of nodes like that don't talk to each other, don't synchronize across everything. You can probably do a lot, but at some point you just are gonna hit a limit, and maybe demand at some point outstrips or outpaces how much supply you can provide with like better hardware and whatnot, which is the classic, Ethereum Solana debate. So from my point of view, what I've envisioned is that, how like when you go to Docker and Docker on your top right runs in an icon, and it just runs on the background and it runs a bunch of containers. So here's like my, galaxy brain way out there, take sci-fi thing, and, take it as you will. My ideal take is that you download, the Reth app, you drag and drop it to applications, and then you run it, and it runs in the background. In the background, it would run a stateless staker and execution layer. Why stateless? Because it should take very little resources. And without derailing too much, when we say stateless, it means that it's a node that receives transactions. The block also contains all the information required to execute these transactions. This is typically called a witness. And by doing this kind of like stateless execution, you're able to follow the chain without having to have, a terabyte worth of data on your drive, which is very important. This is the so-called stateless Ethereum. Many question marks on how we get there. So it might not be 2 or 3 years. Many ways to go about it. There's vertical trees. You can maybe do it with like Binius and binary trees. There's like many ways to go about it. But the core thing here is that like at the foundation, the clock is an Ethereum L1 stateless node. And like in my mind, I relate to Ethereum as, the NTP, the clock protocol of the new world. Now, on top of that, you have a bunch of layer 2s running. So again, the layer 2s that you would run, you could opt into running them in this like little app that runs on your laptop on the top right of your screen. That app would run a couple layer 2s. And these L2s, they would, for example, facilitate the payments layer of all of this. So the Ethereum part just facilitates maybe big settlement, maybe the clock, but like most of the execution definitely happening on L2. So this is like a tale again as all this time. This is like the vision that like I subscribed to working on from the beginning, and I still believe that heavily. Now, the more interesting thing that happens is that, okay, what do you do on top of that? Well, what I would really like to happen is that anytime your machine has any idle resources, so let's say you have 5%, 10% CPU time that you're not doing anything with, you have maybe a terabyte lying around, you have some memory, you have something lying around, this like little Reth app on the top right of your computer says, hey, do you want to earn $10 for leasing part of your compute or your drive or your storage? And this has to like operate like with like this has to like work on top of a payments layer, on top of like a decentralized network. And like many people have like gone about like trying to do things about this, like way back when there was a Golem, there was iExec. The whole idea is like not new by no means, right? But I think path dependency is like a real thing, and it really matters. How do you execute to get there? How do you get everyone to run nodes to get to that world? That's why for us it's very important that Reth is used as a library and as a node, because then everybody will be familiar with the Reth APIs. And at some point, there will be enough people running Reth on L1, on L2, that you won't need necessarily, the Mac that I'm like having this call on to be running it. There's going to be both some servers. There's going to be my local Mac that run it, and they all form a decentralized compute network or a decentralized cloud. So my ideal case would be something which is able to run any kind of computation that's like idle, that any hardware that's idle can run any kind of computation. That might require using some kind of like snark to do the verifiability. It might require using some trusted execution environment. God knows what that will be. But like what matters to me a lot is that the whole stack can like be run like at a minimum like locally, and it doesn't need to be the highest performance parts. It can be parts of the whole thing. So again, stateless Ethereum is useful because you can follow the chain without running everything. That's why there's going to be probably many L2s that like can facilitate specialized operations. So not everyone will need to run every L2. And then on top of that, you will have services that like run parts of things. So for example, if you have a machine learning model, you would have parts of the weights living on my machine, parts of the weights will be running on your machine, and maybe we can do some inference that goes between the two of us. Another case would be that I find like really interesting is just like all of the common use cases that you see today on bridges or on anything that's like AVSs or symbiotic networks. I think all of these things can be captured basically or encapsulated in this like little Reth icon that would run on the top right of your screen. So I really like that as a abstraction, that all you get is like a little icon on the top right, and like it pays off like your machine basically with the idle resources while it's charging in the night, and that bootstraps a decentralized cloud. But to bring it back down to reality, because I think we can ideate world computer visions all day, I think it's going to be really important that you have Ethereum L1, a bunch of L2s, and maybe some off-chain services to facilitate things until we get there. And the L2s will be running the DeFi ecosystem. Like anything higher performance, there will probably be localization. So the DeFi stuff will run on a DeFi set of chains. The things that are like very payments related might like need to like live on a higher throughput chain that like doesn't have like strict total ordering. If you're doing something with a game, maybe you need to do something different. So I think I definitely subscribe to the app chain vision for all of that. I think people want you to believe always in tribes and false dichotomies. I think that the answer is always yes, everything. There will be super chains that like host multiple L2s. There will be one gigantic chain that hosts a lot of applications. There will be other specialized things. Like it's really hard to say today what will work, just because and don't kill me, but it's kind of early, right? It's like 10 years in. People are like we always say that, but it's still day one, like in many ways, in the sense that if you look at rollup.wtf that Conduit built, the whole ecosystem is not doing consistently 100 megagas per second. And 100 megas per second is not a lot. It's literally not a lot. And one would say that once you have like much more demand, only then true specialization requirements will arise. Because right now, like any specialization requirements that arise, or like any like tribalism that you see, it's kind of downstream of narrative, and downstream of frankly like various fundraising dynamics behind the scenes. So I don't think that it's I don't think we're at the point where we can make an educated call on what the case will be, like A or B, A not B. So yeah, my take always has been that it's going to be all of them, and you just cannot predict really. And like anyone that like tries to like go on the one side or the other, there's some kind of personal incentive behind.
Yeah, I really like that vision. I feel like, I mean, the having a stateless node on your laptop, I mean, you also basically get your own direct access to these internet utilities, right? Like you can send payments to anyone, you can do all of these things, and then the actual compute is being run on this mesh of like everyone else's devices.
Yeah, I would recommend everyone in your audience to read, like there's a great blog by the Tailscale CEO called The New Internet. It's an amazing read showing how you literally have centralized intermediaries just because like there was no better network topology at the time, and the P2P network just didn't take off, whereas Tailscale is a VPN. But like a VPN is like just like a very like people relate to VPNs as like software to do piracy. They don't relate to it as software that enables you to bootstrap, locally sovereign networks that don't rely on like big intermediaries. So I think like all of these like decentralized web, decentralized cloud visions that like got us engaged in crypto in the first place, I think the vision is still very much alive. And I think we might be at the point where we can actually execute on it. Whereas, 10 years ago, we had the vision, but we didn't really have the technical chops. I think now we're starting to have the technical chops. And again, I don't want the narrative to run ahead. So like being very present to things, we're like at sub 100 megagas per second. We have a lot of work to get the gigagas, like no real off-chain services like, that are decentralized really exist yet. So you need to like maintain a lot of sobriety while doing all of this, while kind of retaining the original excitement that you have for this vision.
Yeah. Why do you think it matters for us to have this truly kind of decentralized mesh, this is running on our laptops vision of this world computer? Like, to me, there's something really aesthetically beautiful about that idea of like, it's like it's a real kind of internet in a way. And if I think about, I feel like when I kind of reason about this, I'm always kind of going to some, aesthetic or like, this, it feels more elegant in a way. And if you are able to, if individuals have this kind of like agency over their interconnections and access to information and access to money and resources and all of this stuff, this is just like a really powerful thing to like build into human civilization at this point in our longer journey. But how do you relate to this? Because it's also like we don't need to do this, right? Like we could also just be more practical and more pragmatic, and use some bigger computers in the mix here.
Totally. And I think many people will always tell you, hey, you want decentralized, you're an idealist, you're not like down to reality. Well, I'll tell you that a distributed network should actually be cheaper and faster than a network where you need to like go and hit a central server. Why? Because the compute and all of the resources that you want to access can actually sit closer to you, and they don't need to come from a hyperscaler that has a very clear commercial incentive to like, eat you up on the prices. Like if it comes from the neighbor, and that was like also another common project like from like many years ago, which was called, Grid Plus. Again, all of these ideas exist. If you would get the resource that you need from a local network that is like closer to you, you lose less on the latency because speed of light of a packet going back and forth, or, in the electricity example, obviously, you lose power the farther away something is. So I would say that you can actually do faster and cheaper if you're on the so-called edge of a network. And this is like in enterprise SaaS, there's the whole buzzwords around edge computing, serverless edge, all of that stuff. I actually kind of like it. Like Cloudflare is doing a lot of that. Cloudflare started as a CDN, where the idea of a CDN is, okay, let me place like a bunch of servers close to consumers so that they get lower latency. And they realized, oh my God, people don't just want to serve static content, they actually also want to do work. But if they're gonna go to the Google server, why don't I just place the compute where my CDN was? And so it's the same principle if you think about it. So to anyone saying, look, this is like too idealist, like my answer is like always like, look at what Cloudflare is doing or what all of the edge compute guys are doing. Something will work in that neighborhood. I think it's too early to say what will work, but something will work, and that's what we're going for. And these are the practical, quote unquote, business requirements. Faster and cheaper. Like if you want faster and cheaper, if it lives closer to the edge and it comes from idle resources that wouldn't do anything, I would think that you can achieve that. And then, of course, I think that privacy is super, super important. We're obviously in an era where global surveillance just like will keep getting worse unless the defenders level up. And I just think it's important to arm everyone with defensive technology like that.
Hey, I have a small ask here. If you've been listening to these conversations and want to support what we're doing here, I would really appreciate if you leave a rating and a review for the podcast. It might seem like a small thing, but it actually makes a big difference to help other people discover the show also. Thank you, and I'll see you again soon.